funky.
Hey you guys, welcome back to my channel, and I hope you guys are having a good day. In today's video I'm going to be going over vector diagrams, and yeah, let's just go ahead and get started. Okay, so vector diagrams, I don't know where I was going with that, but yeah. So I'm just going to be going through this practice problem that we had in school to kind of help you guys learn how to do it, I guess, if you don't know how to or you don't understand the whole concept of it. And yeah, let's just go step by step how to find the magnitude and the direction and all that good stuff. So let's just get started. Okay, so this is a word problem that I just summarized because I was not about to write everything. Okay, so you have a plane that is flying 890 meters per second east, and so let me just draw like a little thing up here. So you have east. Okay, so your plane is flying 890 meters per second east, and I figure you always want to label the stuff, and so you go this way to the east, 890. I'm just gonna put east, and then the wind is blowing 140 meters north, and so it goes upwards because north is this way, 840 north, and so we always draw it into a right triangle because that's just how they do it, I guess. And so your little delta is going to be down here because you always want to put your delta where you first start. So you start over here with this line, so your delta is going to go right there. And so if the plane is flying at 190 meters per second, what is the magnitude direction of the resultant velocity of the plane with the wind? And so first you want to draw your vector, and you always want to draw the longer vector first, and that is 190 meters per second because that was longer than 140, and you want to label everything. And so to find your magnitude, what you want to do is do Pythagorean Theorem because this is already shaped into a right triangle, and so you just want to do c squared equals a squared plus b squared. So let me write that. And it doesn't matter which one's your A or your B as long as you don't get your hypotenuse mixed up with the other ones. And so you have A squared, you have A and B. And so you want to do c squared is equal to, because your hypotenuse is your C. Let's say this is A and this is B. Okay. And so let's say 190 squared plus 840 squared. So c squared is equal to 190 squared plus 140 squared, 55,700. And so now to find c, because we need c and not c squared, you take the square root of that. So the square root of 55,700 is 236. So that is your magnitude because this hypotenuse is equal to the distance that was covered between the both of these. So basically it's equivalent to this and this, and so that's your magnitude. So to find your magnitude, you always want to do Pythagorean Theorem and be mindful of what they do give you. If the problem would have said the plane was flying, I don't know, northeast, that probably isn't going to be your A or B. It will probably be your C because northeast would be at an angle like that, and that definitely isn't straight. It looks more like the hypotenuse, so you want to be mindful of the words when they give you word problems and stuff. So to find your, what's the other one? Your direction for your resultant velocity. So this was a drawing, and this is your resultant velocity. That's your delta, and that is the directions. So we use inverse tangent to find the degree or whatever. And so you put this where you start, and then let me just work it out. So you have tan is equal to opposite over adjacent. And that's basically geometry, I believe, Sakatoa. And so opposite over adjacent. And so the reason why we put this degree, so we can figure out which one is opposite of the degree and which one is adjacent to it. And the opposite in this case is 140, and the adjacent is 190. So you want to do tangent is equal to 140 over 190. And in this case, we have to do the inverse tangent. And a very important thing for my people who have the mechanical for my people who have the graphing calculators, you always want to make sure that your calculator is in degree mode right here, or you're gonna get the answer wrong. Okay, so inverse tangent, you want to do second tan, and that gives you inverse tangent. And you want to put your opposite divided by your adjacent, and that gives you 36.384 blah blah blah. So your opposite, your direction, is equal to 36 degree, 36.4 if you round it degrees. And the last crucial information I need to give you guys is for the directions. You see how the problem was with north and east, and you can't just say okay, so it was going 236 meters per second and at 36.4 degrees northeast, or east north. Doesn't make sense, nobody ever says that, but northeast, you can't say that because it's not really specific enough. And my teacher explained it like, if you had like an angle like this and it was right here, and this is 45 and this is also 45, and if you were to tell somebody, okay, northeast, it could lead to two different ways, and you want to be specific when it comes to like these directions. And so you have to be specific and make sure you say the short of the longer side. So basically in this case, it would end up being north of east. I totally forgot to write the north out, but it'll be north of east because the shorter side is with 140, which is your north, and the longer side is 190, which is east. So it will be north of east. And don't ask me, it's physics, I didn't make it up. So yeah, so let's just go over it. To find your magnitude, you have to find your hypotenuse, and for that, since you can make up a right triangle out of the two vector diagrams connected, so to find the resultant vector, which is your hypotenuse, which is also your magnitude, you just have to do Pythagorean Theorem. C squared equals a squared plus b squared. Doesn't matter which one's your a or b. And to find the direction, you have to do inverse tan, which is opposite over adjacent, and just make sure you put second tan, opposite over adjacent, and get your degrees. Make sure your calculator's in degree if you have a graphing calculator. And the shorter of the longer side, which is north of east. And yeah, that's that. Also, these are my notes if anybody wants to see that or wants to like screenshot it and use it to like learn how to do vector diagrams. So basically this is just a problem in the question, and then I just labeled the steps. So the first step you want to do is find your direction using Pythagorean Theorem after you draw your stuff and label it. And the second step is finding your direction using the what are they called? I don't remember. They have a name, like the whole Sakatoa thing has like a specific name, but I don't remember. But you use the tan equals opposite adjacent, inverse tan, and all of that. And then the short of long side that you use for the direction as well. And that's just how you write everything as an answer. And that's it. Okay, so this page basically also goes over the same thing that I just showed you guys on the last page, but this is a different problem. And yeah, it's just a different problem if you guys wanted to see how it's done with a different problem, set of numbers and all that, but it's basically the same concept and stuff. And yeah, it's also if your opposite happens to be bigger than your adjacent. Okay, so like I was saying, if your opposite happens to be bigger than your adjacent, it doesn't matter as long as you know you did it right and you put the delta where it started at the starting point, like when you first started drawing the right triangle or like the vector diagrams. And yeah, you wouldn't be wrong as long as you know you put it in the right place and the opposite is actually the bigger number. But 9 out of 10 times the opposite is going to be smaller, but I've had problems where the opposite was bigger and the answer was still right, so there's that. And so basically this is just a drawing and me labeling like opposite, hypotenuse, adjacent and all that stuff. This is a drawing, so you started with south and then you moved here and then you drew the line, so it's, you know, it started here because the delta that's right there, this is your resultant velocity, resultant vector, not velocity. And starting point, Pythagorean theorem, how to do Pythagorean theorem, the directions, how to find directions, and the short and long thing that I was talking about. The shorter side is obviously the west and the longer is the south, so west of south, short of longer, get it in your head. And that is how you would write it out. This is Pythagorean theorem. This is the whole opposite, the inverse tangent. I keep saying that wrong. The inverse tangent and the short of longer, and that's it. That's the end of the video. Thank you for watching. I'll see you guys in the next one. Bye guys.